So this video is going to show you how to do the problems from the Module 11 I Can practice. So we are going to start by matching each radical expression with its equivalent rational exponent. In fact, I wouldn't even look at these guys over here. I would just convert all of these so you make sure you've done it correctly. So the root is what goes at the bottom. So the whatever's on the inside becomes the numerator. So it should be w to the 5/3 power. And then the root is at the bottom. So w to the 3/5 power. The root's at the bottom. Remember, there's an exponent of 1 in here. So w to the 1/3 power. It's always assumed that there's a 2 out there if there's nothing written. So w to the 5/2 power. So for my version of this, it looks like I had E, 3/5 was C, 1/3 was F, and 5/2 was B. In this one, we have to convert from the fractional exponent back to the radical. And again, the root has to go in the bottom, or the root has to go in the bottom of the in the radical. So this piece here should be in the radical. So that one looks correct. Let's look at the other. So this one, the cube should be in the radical. That one's out. This one, the 4 should be in the radical. That one's out. This one, the 5 should be in the radical. That one's out. So it has to be answer choice, the first answer choice. All right. So when the bases are the same and you're multiplying, I would go ahead and add my exponents. So 27. And the 1/3 plus 2/3 is 3/3. Well, 3/3 reduces to 1, so my final answer is just 27. We are super lucky. All right, on this one, we want to try to rename 4 as something squared so that we can get these to cancel. So another name for 4 would be 2 squared. The 2's cancel. So I've got 2 to the 5th. And let's see, 2 to the 2nd is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th has to be 32. We've got to simplify everything, so I'm going to follow my rules the best I can. First of all, I can distribute this in, and when I have a power to a power, I multiply the exponents. So I would have a to the 4 times 4, which is a to the 16th. B to the 1/2 times 4, which would be b squared. And then here you'll notice we've got the 12th root of b to the 12th. Well, those would cancel, and I would just get b. My bases are the same, which means, and we're multiplying, which means I have to add the exponents. So I've got a to the 16th. 2 plus 1 is 3, so b cubed. All right, we need to simplify, so I'm going to set up my 2 boxes. So I can take the square root of anything here, and I can't take the square root of anything there. So I'm looking first. 16 I know is a square number, so it goes in the can-do box. I'm going to pull out as big of an even number as I can on the exponent. So I've got r to the 4th, nothing left over. For s, I would have s to the 4th, but it has 1 left over. So I'm going to take the square root of this box. When I take the square root, the root sign goes away. So the square root of 16 is 4. The square root of r to the 4th, remember we divide by 2, would be r squared. Square root of s to the 4th would be s squared. And then just the square root of s. Somehow, oh no, it's not. All right. I am going to choose to do what's on the inside of the parentheses first. So we know that division turns into subtraction. So I've got a to the 7/3 minus 5/3. We're going to keep that 49 in the bottom. And we've got to the 3/2 power. 7/3 minus 5/3 is a to the 2/3. Instead of writing 49, I'm going to rewrite it, because eventually I need a 2 in the bottom. I'm going to rewrite it as 7 squared. And then I'm going to distribute this in. Remember, a power to a power means we multiply the exponents. So we've got a to the 2/3 times 3/2. And 7 to the 2nd times 3/2. These cancel, those cancel. I've just got an a in the top. This cancels. I've got 7 cubed in the bottom, and we know 7 cubed, if we look at our cube numbers list, is 343. So we're not supposed to leave radicals in the denominator. That's our hint on this one. I'm just going to take the square root if I can. I know the square root of 81 is 9, but I don't know the square root of x. So I need to rationalize the denominator. To do that, I'm going to multiply top and bottom by square root of x. So we've got 9 square root of x. The square root of x times the square root of x is the square root of x squared, which if I take the square root of that is just x. And this is probably how the answer would get left. All right, on this one, we're looking for cubes. So I'm going to do the same thing I did before, but with the squares, I'm going to split it into I can take the cube root of it and can't take the cube root of it. So I'm looking for cube numbers. 256, I'm double checking. I'm pretty sure that is 4 cubed, if I remember right. Nope. Let's try 16. 16 times 16. Nope. Oh, it's 4 to the 4th. Okay. So this 256 equals 4 to the 4th power. So what I would want to do is I would want to pull 4 cubed out there and leave another 4 here. Then I'm going to pull out anything that is a multiple of 6 in the exponent. So x to the 6th would all be there. Y, I'd pull out y to the 6th, then I would have 2 left over. I'm going to take the cubed root of this. So the cubed root of 4 cubed would be 4. Remember, we're dividing the exponents by 3. So cubed root of x to the 6th would be x squared, y squared, and then I just keep the cubed root of 4y squared. All right, number 10. So we got to solve the equation, so I need to get it down to the radical isolated first. So I'm going to add the 7. And chances are I may not put these multiple choice on the test. It might just be an open-ended one, so you got to be careful, okay? So we've got the square root of x plus 3 equals 6. I'm going to square both sides, so you'd have 36. And then you have x equals, I subtract the 3, and that gives me 33. As long as I put it in, don't get a negative under the radical sign, I'm good, so 33 is a good answer. All right, I have to undo the square root by squaring both sides. We've got x plus 72 equals x squared. If I've got a quadratic, that means I need to get it equal to 0. In order to keep my leading coefficient positive, I'm going to choose to move these to the left. So to move the x, I'm going to subtract it. To move the 72, I'm going to subtract it. I now have a trinomial, so I need to do a magic x. Two numbers that multiply to negative 72 and add to negative 1 would be negative 9 and 8. I don't have a leading coefficient, so I get to use those. So I've got x minus 9 times x plus 8. Then I'm going to do the zero product property. And I am going to set them both equal to 0. I'm going to add 9, so I get 9 as an answer. And I'm going to subtract 8. Now, there's a catch on this one. I have to check it back in the original. And remember, my original looks like that. I am not allowed to have a radical equal a negative number. So if I put the 9 in, it's fine. So that's a good answer. If I put the negative 8 in, I end up with a radical equaling negative 8. I can't have that. So this is an extraneous solution, and my only answer is 9. All right. Then I'm going to look at 12 here. So to do 12, I want to get both of these radicals on opposite sides. So I'm going to add this one to the other side. So you get the square root of 3m minus 8 equals the square root of m plus 6. To undo the square roots, I square both sides. So I get 3m minus 8 equals m plus 6. And then we're going to move this m to the left by subtracting. So 3m minus m is 2m. I'm going to move the 8 to the right by adding. So 6 plus 8 is 14. And then I'm going to divide by 2. So 14 divided by 2 is 7. And it looks like those would probably be okay in there. All right, this one here is probably the trickiest one of all of them. So we need to get rid of the radical, we got to square both sides, and on over here I have to square it with the binomial. So I'm not just squaring each individual part. I'm having to remember squared means on that. Sorry, it zoomed in weird. Keep. All right, so squared on that means that we have to write it twice. So I know that these guys cancel, so I've got x plus 15 equals, and I've got, so write it twice means x plus 3 times x plus 3. That means I'm going to have to FOIL. So x plus 15 equals x times x is x squared. X times 3 would be 3x. I have that again in the middle. And then 3 times 3 is 9. I'm going to combine my like terms. So x squared plus 6x plus 9. I need to move the x and move the 15. So when I move the x, I'm subtracting the x over. So 6x minus x is 5x. I'm going to subtract the 15 over. So 9 minus 15 is negative 6. Yep, okay. Then I've got a trinomial, it's equal to 0, so I'm going to do a magic x, so two numbers that multiply to negative 6 and add to 5. So we would say 6 and negative 1. There's no leading coefficient, so I don't need a box. So we've got x plus 6 times x minus 1. I'm going to use zero product property, set them both equal to 0. And we've got x equals negative 6 and x equals 1. But I got to be careful and make sure I can put those both in. So remember, it has to go in here. So we've got a radical with x plus 3. So I have to make sure that this doesn't come out to be negative. When I put a negative 6 in there, I get negative 6 plus 3 equals negative 3. So I'd have a radical equal to a negative. I can't have that. So negative 6 is extraneous. If I put a 1 into the x plus 3, I'd get 4. So that's positive, so that's an okay answer. So my answer has to be 1.